Welcome back. In this morsel, we are going to discuss the job scheduler in more detail. We will delve a bit deeper into the HPC resources that the scheduler manages, look at the job queue in depth, and talk about some commonly used workload management systems in HPC today. Without a job scheduler, our cluster would be a bunch of servers trying to run different jobs that would likely interfere with one another. For a large cluster with multiple users, each user would have no idea which compute nodes and CPU cores to use, nor would they know what resources are available on the system at any one time. These are the problems solved by batch systems using job schedulers. Schedulers are essential for sequentially queuing jobs, assigning priorities, distributing, suspending, killing, or otherwise controlling jobs on the cluster. HPC systems are made up of many resources, such as GPUs, servers, memory, storage, and CPUs. Even software and networks are all considered to be part of the resources that HPC provides. When a user submits a job on the HPC system, they specify the type of resources that they need. For example, CPU nodes, GPU nodes, or even high memory nodes. Some jobs may require many processing elements or CPUs, while other jobs may require fewer processing elements, but lots of time to run on the system. Some jobs may require other resources, such as a fast interconnect like InfiniBand, or lots of system memory. When a user submits a job, the job scheduler assigns which resources the job is allowed to run on, ensuring that they don't overlap. At some point, the cluster will fill up or nearly fill up with jobs. At this stage, the job scheduler holds jobs in the job queue. When a running job completes, making more resources available, the job scheduler allows queued jobs to run. Another task of the job scheduler is to assign a priority to each job waiting in the queue. High priority jobs sit at the top of the queue, waiting for compute resources to become available. Every couple of minutes, the job queue is re-evaluated. Adjustments to the queuing order are made based on a number of factors, like how long each job has been waiting in the queue and their assigned priorities. Another task of schedulers is to enforce the resource limits set by the system administrator. Common limits include the maximum number of jobs a single user can submit, the maximum number of CPUs a single user or group can request on the system, or even the maximum number of CPUs that a single job can consume. If the limit is exceeded, the job scheduler will place the offending jobs on the blocked queue. Jobs in the blocked queue will not run, even if there are compute resources available that meet the job's requirements. As jobs start to complete, the number of user or group jobs in the system may drop below the threshold, allowing the blocked job to enter the eligible queue. As you can see, there is a lot you can do with schedulers. Before we dive into the next video and discuss job scheduling policies, let me introduce some popular batch scheduling software used by many HPC centers. There are two main streams of workload management software, commercial and open source software. Commercial software must be purchased. Two common commercial options are PBS Pro by Altair and Spectrum LSF by IBM. Both options are available to install on the Linux and Windows platforms. Altair also have an open source offering, OpenPBS. Open source batch systems are free to download and use. OpenPBS, along with htCondor, have offerings for Linux and Windows, while Slurm Workload Manager is only available for the Linux system. In the next morsel, we will discuss some common scheduling policies enforced by batch systems.